Alright, so I posted a little floated note. I kept it as a floating note and I kept it up here so we can always refer to it. We're going to see how that applies here. The main idea is to turn this into the left side, a U and a DV. So you can always think about these things as items in some sort of bucket. Here, I'll give you a little visual. If you have the integral of A times B times C times D times E times whatever dx, some of these items will go into the U bucket and some of the items will go into the DV bucket. Once you put, say, for example, say these items, you put them there, the rest of them you have no choice, you got to put them there. Then you can complete the dictionary here by finding out what the, you need to find out what the U is, what the V is, what the integral of, what the, and you need to put them into this form. And a lot of times this will make it a lot easier than the original one. Talk is cheap. I think we should actually do to do a problem. Let's see how this one goes. We're gonna, you got three items here. You got the X, you got the U, you got the cox, and you got the dx. Some of them have to be U and the rest of them has to be a dx. I'm going to call the X here, I'm going to call it U. I'm going to say U is equal to X. That means that I have no choice, but the rest of it has to be a dx. So the cosine X and dx has to be a dv, I mean. See, so therefore this is my U bucket, this is my dv bucket, and together the whole integral is a U dv, just like the left side of this side. Now I complete the dictionary here. This will be sort of a dictionary. By the differentiating on this side and integrating on this side, I will get my, I differentiated both sides. Here I do the integral on both sides, so v is equal to sine of x, the derivative of sine is cosine, and so therefore this integral, which is x cosine of x dx, I can translate it into, this is integral of u dv, and then I can say, well, that I can use my statement here, that must be equal to uv minus integral of v du, which would mean that that's u times v, that's x sine x minus integral of v du, sine x dx, sine v du, that's v du, sine x and dx, right here. Okay, just by plugging it into this formula. That turns out to be really nice because look, this integral over here was difficult, but we turned it into using v's, used the integration by parts statement, turned it into this, and this part is easy because it has no integral, and this part has an integral, but this one is a lot easier than the original one. In fact, you can eyeball this one. What's the antiderivative of sine? Of course, that would be cosine. So that you have x sine of x plus cosine of x plus a constant. Yippee-ki-yay. Right? And then we'd be done integrating this. It's easy to check to see if you did it right. I know. Check to see if we did it right. You could take the derivative of this and you see it's equal to that. That's our first integration by parts. It's just a matter of separating this into u's and dv's. Alright, that's like the easiest example. Come back for some more interesting examples if you like. See you guys.